truth is the daughter of time, and I feel no shame in being her midwife. Johannes Kepler. This video presents the ballistic law applied to light emitted by a source in motion. We use the expressions observer in the absolute frame and observer in an inertial frame, meaning that these hypothetical observers observe phenomena as they are in their frames. These expressions may be eliminated to avoid confusion with human observation and say directly how the phenomena are, as in Newtonian mechanics. The expression local observer is particularly essential. A local observer perceives the phenomena through light coming directly from a source or reflected by objects from the observer's frame or others, as well as through partially reflected wave fronts of light by some particles of the transparent medium, such as air, through which light travels. Therefore, a local observer perceives a physics phenomenon differently from the reality of Newton's laws. Nevertheless, we understand reality better by applying Newtonian laws and local observation of light. This study considers light propagation as a continuous phenomenon in which each wave point is a wave front. The physics phenomenon of light propagation is that light, as a massless entity, inherits the velocity of its source as massless balls. The ballistic law of massless balls applies to light. A wave front emitted at the velocity c by a source at the velocity v travels in the absolute frame at the propagation velocity CSA, given by the vector sum of the emitted velocity c and the source's velocity v. CSA equals c plus v, unless a restriction arises in its propagation direction. Velocity CSA varies in direction and magnitude according to the velocity c direction from the velocity v direction. Suppose a light source at rest in the absolute frame emits waves in all directions. The spherical wavefront has its center at the source at all times. Waves are uniformly distributed to the source, and waves travel at the emitted speed c, with wavelength lambda, period t, and frequency f in any direction. The phenomenon is a sphere with its center at the source at rest, continuously expanding with a radius increasing in time with ct. At each fixed point, a local observer observes the wave coming from the source with a delay, according to the time from its emission, traveling at the speed c, with wavelength lambda, period t, and frequency f. The figure illustrates the circular wave front emitted in the paper plane by a light source at the origin of an inertial frame that travels at the velocity v in the absolute frame. The figure presents the case when c is greater than v. To scale for c equals 3 meters per second and v equals 2 meters per second. At the initial instance at 0.01, the source emits a spherical wavefront. When the source is at the 0.01, the circle of the instantaneous velocity c, with the center at 0,1, belongs to the inertial and absolute frames, and the instantaneous propagation velocities CSA originated at 0,1 and ending at the circle with the center at the point 0,1 prime belongs to the absolute frame. Both circles have a radius of 3 meters. After time t equals 4 seconds from the initial instance, the circular wave front emitted at 0,1 is at 0.02 and has a radius of 12 meters. A specific velocity CSA applies to each wave front emitted in the absolute frame. The vector sum of velocity c of the wave front emitted at 0,1 in the direction 0,1b1 and the common velocity v along 0,101 prime gives the propagation velocity CSA along the path 0,1b1 prime traveled in 1 second. With the same reasoning, each velocity CSA can be distinguished from the multiple lines. The wave front emitted at 0,1 in the direction 0,1b1 prime travel the path 0,1b2 at speed CSA in the absolute frame and the path 0,2b2 at speed c in the inertial frame. The traveling direction 0,1b1 of the wave front does not change along 0,1b2. A local observer at point b2 observes the wave front coming from 0,2, not 0,1. Each emitted wave front inherits the velocity of the source in the absolute frame, such that in the source inertial frame, waves in any direction travel at the emitted speed c, with wavelength lambda, period t, and frequency f. The phenomenon in the inertial frame of the source is like that in the absolute frame. In the absolute frame, the phenomenon of the inertial frame travels at the velocity v.